Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Vectors. For this lecture, I am using the work of one of my best students, Miss Sayyida Fiza Kaisar of class 2020, the Lyceum. Comprehensive concepts plus regular practice is equal to A star. This is the formula of getting the A star. An important advice for me and for everyone: we should be well mannered. In O levels, we did vectors in two dimensions, like x and y. So if we have this point A, 2 and 3, we can write this point in vector form as OA, 2 and 3. It's here. And this OA means the position vector OA. Position vector means if any vector starts from origin, then that vector is known as the position vector. Therefore, this OA is known as the position vector. And this is known as the free vector. And you can read this vector as 2 and 3. This 2 means the x component and this 3 means the y component. And since both the components are positive, so according to head to tail rule, you need to go 2 units right and 3 units up. When we have position vectors like this OA and OB, then we can find AB through this formula, like second minus first. AB means OB minus OA. What if we had to find BA? Then this would be OA minus OB. Second minus first. We have OA and we have OB. OA is 1 and 2 and OB is 2 and minus 3. Therefore, the answer will be minus 1 and 5. This is vector BA. And this is vector AB. You can also use this method for AB, AO plus OB, but this method is lengthy. So it's better to use this method for AB or BA. In add math, students did I and J representation. So if we have this vector OA 3 and 2 in column vector form, then we can express this column vector in IJ form as 3i plus 2j. 3 means I means the x component and j means the y component. So for x component, we write 3i and for y component, we write 2j. This is the positive x direction. So this is positive 1i, 2i, 3i and so on. 1j, 2j, 3j and so on. This would be negative I, negative 2i and so on. Negative j and so on. And this I cap, this cap means unit vector. This is I cap and j cap. I cap means the unit vector of x-axis. This is the unit vector of x-axis. Unit vector means a vector whose magnitude is 1. And j cap means the unit vector of y-axis. I will discuss the unit vectors concept in this lecture later. Well, in books you will find this notation instead of this, because in books they write I as a bold, in bold, and in writing we write I cap. So we use this notation. In books you will find this notation. They both means the same thing. In general, if we have this is AXY, then OA will be X and Y. In IJ form, this X will become XI cap plus YJ cap. So this column vector in IJ form would be like this. You can write this column vector in this way in IJ form. Well, If if you will find this IJ form difficult, then there is no problem. If the question is given in IJ form, you can convert the question in column vector form. Solve the question in column vector form and give your answer in IJ form. Since this vector is given in IJ form, so you can write this vector in column vector form. This is 7 minus 2. This is 2 and 1. So first write them in column vector form and then find the answer. Like the question is find AC. So AC according to head to tail rule is AB plus BC. This is the answer of AC. But since the question was given in IJ form, therefore you have to give your answer in IJ form. So just represent this column vector in IJ form. So it's very simple. Whenever question is given in IJ form, always express those vectors in column vector form, solve your question, get the answer in column vector, and then convert that column vector in IJ form. This is the best way. Parallel vectors. This is basically the review of O level. You did this in O level. Parallel vectors are multiples of each other. Multiple means half, twice, thrice, etc. If AB and CD are parallel, then there are two different ways for the parallel vectors equation. So we can write AB is K times CD, like AB is multiple of CD, or we can write CD is multiple of AB. They both are fine. You can use any one. Well, if K is positive, if this K is positive, then both the vectors are in same direction. If K is negative, then vectors are in opposite direction. Collinear points. You also did this concept in O levels. If 3 points lie on a straight line, then those points are known as collinear points. So there are 3 vectors in the same direction: vector AB, BC, and AC. And these are the possible vector equations for collinear vectors. Since vectors are multiple, so we can write AB is multiple of BC, or AB is multiple of AC, or AC is multiple of BC. You can write anything. You must know these equations. If, let's suppose, if AB is given and AC is given, then you should use this equation. AB is multiple of AC, or AC is multiple of AB. Always write the complicated vector on left side and the easiest vector on right side. Unit vectors. Well, unit vectors are denoted by a cap, this notation, the cap notation. This is known as the vector AB, and this is known as the unit vector AB because of this cap. And unit vector means a vector whose length is 1. I mean, if this is the unit vector, then its magnitude will be 1. This is this is meant of a unit vector. Like unit vector means a vector whose magnitude is 1. Well, how to find unit vectors? So if this is the point A, then in vector form we can write OA. This is XY. First we need magnitude of OA. So the magnitude of this vector is x square plus y square. And this is the formula of the unit vector. Unit vector is OA cap, OA divided by its magnitude. If you divide vector by its magnitude, then you can get the unit vector. If you will divide xy by this magnitude, then you will get the unit vector OA like this. You can write xy here as well, xy upon its magnitude. They both means the same thing. You are dividing xy by its magnitude. Example, this is A. In vector form, it will become 4 minus 3. This is the magnitude of this vector. And this is the formula of the unit vector. Vector divided by its magnitude. It's here. You can leave your answer here, or you can write this as 4 upon 5 and minus 3 upon 5. They both are right. And in ij form, you can write this vector as 1 upon 5. This will become 4i and this will become minus 3j. This is fine. And if you want to simplify this, you can write this as 4 upon 5i, 3 upon 5j. Now, let's start vectors in 3 dimensions. This is P3. So, this is the x direction, x-axis, and the unit vector of x-axis is I cap. This is the unit vector of y-axis, and this is the unit vector of z-axis, k cap. I cap means, I means, let's suppose this is I. So we can write this I as, this point as 1, 0, 0. And in vector form, we can write this point as, there are 2 ways of writing this point. Just I or 1, 0, 0. Well, this thing is known as the direction vector of x-axis. So if it's given in the question, the line is intersecting the x-axis, so you need to use this direction vector for x-axis. And this will become, this will become 0, this j will become 0, 1, 0. You can write this in vector form as just j or 0, 1, 0. This is the direction vector of y-axis. This point is 0, 0, 1. In vector form, you can write this as j. Well, this point is 1, has coordinate 1. Z coordinate is 1. So you can write this point as 0, 0, 1. Well, you can express this point in vector form as 0, 0, 1 or k. This is the direction vector of z-axis. Make sure you will learn these vectors by heart. They are here. The direction vectors of x-axis is this, y-axis is this, and z-axis is this. In column vector form, in ijk form, you can write this as just I. This is equal to j, whereas this is equal to k. Position vectors. I already have told you all that vectors drawn from origin. If vectors are drawn from origin, then those vectors are known as the position vectors. So if this is A, then the position vector of A will be OA. You can write this arrow or this arrow. It's your choice. In small letters, we write vector like this. We make this notation. This means this is vector OA. And this is the column vector form of this vector. In ijk form, you can write this as 4i, 5j, and 2k. And you can get the magnitude of this vector. It's 4 square, 5 square, and 2 square. And make sure you simplify this. This is, I think, 3 root 5. Well, if you need the unit vector of this vector, then the unit vector of this vector will be this upon this. Is scalar a product or dot product? I discussed this topic after these two topics, collinear and parallel vectors and unit vectors. Let me first discuss collinear points. If 3 points lie on one line, straight line, then the points are said to be collinear. And the vectors formed through those points are multiples. There are 3 vectors in same direction, AB, BC, and AC. These vectors are multiples of each other. And you can use any equation. Parallel vectors. I mean, collinear vectors from or vectors formed through collinear points are multiples. Similarly, parallel vectors are multiples. I mean, these two types of vectors are multiples of each other. But see, one point is common. So if one point is common, if we have common point in vectors, then that means these points are on a straight line. See, no point is common. Therefore, these two vectors are parallel. If we have a common point, that means these points are collinear. If we don't have common points in multiple of vectors, that means the vectors are parallel. Not like points are not collinear. So you can write CD is multiple of AB or AB is multiple of CD. You can write anything. Unit vectors. I told you unit vectors are represented by a cap, and unit vector means a vector whose magnitude is 1. If a cap is a unit vector, then its magnitude must be 1. And this is the formula of unit vector in small letters form, and this is in capital letters form. You can get the unit vector by dividing vector its magnitude. If you divide vector by its magnitude, then you can get the unit vector. Here is the example. This is point A in position vector form. This will become 1, 4, minus 2. In ijk form, it will become I, 4j, minus 2k. So first get the magnitude of this vector. The magnitude of this vector is under root 21. This is the exact answer, so leave this answer as it is. And this is the unit vector. Vector divided by its magnitude. This is the column vector representation, and this is the ijk representation. An important application of unit vector. The question is, find vector OB whose length is 25 units and is in the direction of unit vector. This unit vector means these two vectors are parallel. So this vector, this is the rough sketch of this situation. So this vector OB is here with magnitude 25, and this vector is unknown. We are working for OB, and this I suppose as unit vector A cap. And we all know, since this is the unit vector, so its magnitude is 1. So this is so simple. You have two methods of finding this vector. Number one, you can say that OB is 25 times of this vector. Like OB is 25 times of unit vector A. And this is the answer of OB, vector OB. And the other method is the ratio method. And this is the easiest method. Anyone can do this method. Write the requirement here and its magnitude here. This vector which is given here with magnitude. So by cross multiplication we have OB. Let me just correct this thing. This is vector. This is not magnitude, because magnitude is in denominator. So write the vector here and its magnitude here, and given vector here with magnitude, and just multiply 25 on this side. You will get this thing. This is vector OB. So this will be the answer because we substituted the value of vector A here. Same answer, C. So you can use any method. Well, the next thing, I left this concept, scalar products. Let me discuss this concept now. Scalar product or dot product. This means if you take, scalar product and dot product means the same thing. And they both means if you take the dot product of two vectors, then you get a scalar quantity. So when you get a scalar quantity through the product of two vectors, then that product is known as the scalar product. Work done is a scalar quantity. Since we are multiplying these two vectors, force and displacement, and we are getting a scalar quantity, work done. Therefore, this product is known as the scalar or dot product. And this is the formula of the scalar product. A dot B is AB cos theta. And you can make cos theta subject. Well, if A dot B is positive, if this result is positive, then we say the angle between these two vectors is acute. If the dot product is 0, that means we say these two vectors are perpendicular of each other, like 90 degrees. So if the dot product is 0, then vectors are perpendicular, or vice versa. If two vectors are perpendicular, then their dot product must be 0. You can also say this as if A and B are perpendicular, then their dot product must be 0. This is very important in vectors. Well, if the dot product is negative, then the angle between the vectors is obtuse. This angle is obtuse. So by observing the answer of dot product, we can guess the angle. Like we can say the angle is acute or right angle or obtuse angle. Now let me do few examples of this concept, scalar product. This is question number 1 from the book. This is the list of questions of this book. If you want to take the screenshot, you can. Now question number 1. This is vector OA, this is OB, and this is OC. And this is the scalar product, the application of scalar product. The question is find angle AOB. And this is the way to find angle AOB. We will use scalar product for that. Remember, in order to get this angle AOB, you need to read this AOB as. If you are working for this angle, then read this as OA dot OB. Always read from the middle point, from center. So you need to find the dot product of these two vectors first. First get the dot product of these two, then get the magnitude of these two vectors separately, and then substitute them in the formula of dot product. This is the formula of dot product. So this is the concept. See the solution. First, this is the formula, and I made this cos theta subject, and I suppose this angle as theta. So first get the dot product. And how to get the dot product, I tell you. You just need to multiply these two vectors in this way. X component with X component, Y component with Y, Z component with Z, and always put plus sign between the numbers. Like 2 times 0 makes 0, then plus sign. 3 times minus 6 minus 18, therefore minus ho jaye, this sign will become negative, and this will become negative. And OA and OB, get the magnitude of this vector. The magnitude of this vector is 7, it's here. And the magnitude of this vector is 10, it's here. So 7 and 10. You can also use this formula. Like this result is, I guess, minus 66. So this would be here. This is the another way. You have two options. You can calculate the angle in this form as well. So by substituting the values of the vectors OA dot OB here and magnitudes here, we can get the angle theta. It's 160.5. You can use any method. They both are fine. And remember, while inversing, always consider negative sign, because you are working for the journal angle. You are not working for the basic angle. So in vectors, you always work for theta or journal angle. Therefore, while inversing, if there is a negative sign, must consider that negative sign with the function. Like cos inverse this entire thing. We ignore negative when we work for basic angle. And in trigonometry, we always work for basic angle alpha. Therefore, while inversing, we ignore negative. But since we are not working for basic angle here, therefore we have to take negative sign. This is very important. Just remember this thing. Whenever you work for basic angle alpha, then always ignore this negative while inversing. And when you work for journal angle, like in vectors, you always work for journal angle. Therefore, always take negative sign with inverse. Cos inverse this entire thing. And the calculator will give you this answer. And make sure you write your answer 1 decimal place, because this is the requirement of the examiner. So this is the way to get the dot product. Let me solve discuss one more question of dot product. This is the dot product question. This one, OQP. So you will write this as QO dot QP. See the solution. We need this angle OQP. So write QO dot QP. QO dot QP, QO QP cos OQP. This is vector QO, this is vector QP, and this is the magnitude of QO. This is the magnitude of QP, and this is angle. So get this dot product, multiply this with 3, minus 3 times 3 will become negative 9, put plus sign, then multiply these two, positive 3, put plus sign, this will become 36, and the result will become, I guess, 30. It's here. And this is the formula of the dot product. And after taking inverse, you'll get this thing. This is the angle OQP in 1 decimal places. I hope you all have understood the concept of dot product and the method to evaluate dot product. Now, let me discuss the leftover parts of this question. 1. Find the vector which is in the same direction as AC and has magnitude 30. This is the best question of ratio method. I told you when two vectors are in same direction, then use ratio method. Find the vector. Now let's suppose that vector be d, small d. You can suppose this as a small d. Find the vector d which is in the same direction as AC and has magnitude 30. This is the magnitude of vector d. So you just need to use ratio method. Get AC first and then use ratio method. And how would you find AC? This is so simple. AC will be OC minus OA. We have OC, we have OA. The solution is here. This is AC, it's OC minus OA, and I'm using ratio method. Like, this is the magnitude of vector D. This is for D and this is for AC. Let me correct this. AC and this is D. So by cross multiplication, and you can write here D. By cross multiplication you can get the answer. And you can do this as well. D upon its magnitude. This is the another way. AC divided by its magnitude. So D upon 30. This will be 6 and this is the vector minus 4, 2, 4. So this will become 6 times 5 makes 30. 5 times minus 4, 2, 4. You can do this in less steps. But since I'm explaining, so I'm doing all these steps. Minus 20, 10 and 20. This is the answer of vector D. You have option, you can use any method. I think this method is simple. Now the last part of this question. Find the value of the constant P for which this vector is perpendicular to OC. Now first get this vector OA plus POB, and perpendicular means the dot product of these two vectors must be 0. I told you when two vectors are perpendicular, then their dot product is always 0. So first work for this vector OA plus POB. This is OA, this is P and this is OB. And this is the simplified form of this vector. Well, since it's given, the vectors are perpendicular, therefore their dot product must be 0. I told you this in scalar products. If two vectors are perpendicular, let's suppose this is vector A and this is vector B. If they are perpendicular, then their dot product must be 0. Make sure you remember this concept. So this is 0 and you just need to multiply the components. 2 times minus 2 minus 4, then put plus sign. 5 times this is this and this. And this is the value of P. Well, in diagram based questions, I'm just giving you one hint, and that hint will be enough to solve any question of diagram like this. The hint is use head to tail rule in the given directions. You just need to use head to tail rule in the given directions. Start from the initial point and reach the terminal point. For example, you need vector OQ. The initial point is O. So you need to start from here and you need to use head to tail rule in the given directions. This is OQ. So to get OQ, you need to start from O. You should work along or parallel to these directions and reach the point Q. So I'm writing the rule here. Start from the initial point, use head to tail rule, and work along or parallel to the given directions. Given direction means the directions of I, J, and K. This means the given directions. So this is the initial point and this is the terminal point. I will work either along or parallel to these directions for OQ. So I will work in this way. OD plus TQ. In this way I'll get OQ. And the important thing is we don't have DQ, but we can get DQ. We can get it easily because this is the cuboid. This is cube. So this every face is same. So this is the midpoint of OB. And you can suppose this as M. So instead of finding DQ, you should find OM. And OM is half of OB because M is the midpoint of OB. So get OM, that will be equal to DQ. And we have OD. OD is 6K. This is 6K. And every side is 6 because it's cube. This is 6I, this is 6J, this total is 6J. And it's given AP is 1/3 of AB. So AB is 6J, therefore AB will be 6 upon 3 makes 2. This will be 2J. And this will be 4J. So, number 1, we are working for OQ. So, for OQ, this is OQ. OQ is OD plus DQ. OD plus DQ. And I told you, we will not find DQ, we will find OM, which is half of OB. So, instead of DQ, we can write half of OB. And this is the value of OQ. And the second thing is we need PQ. So PQ, we have this option. We have two options for PQ. We can either use this option, PB, BF, FQ. And the second option is PA, AO, OQ. This option is better. We have PA, we have AO, we have OQ. So it's better to use this option for PQ. I'm using this option here. PQ is, according to this diagram, it should be PA plus AO plus OQ. This will give you PQ. And PA is negative 2J because AP is 2J and we are going in opposite direction. And OA is 6I, therefore this will be negative 6I. And OQ, we have OQ. OQ is this, 3I, 3J and 6K. 3I, 3J, 6K. So the answer of PQ will be minus 3i and plus j and plus 6k. This is the way we can get PQ. I hope you all have understood the technique of getting the vectors, the concept in fact. Always, start from the initial point, use head to tail rule and work along or parallel to the given direction. Just that, use this method and you can easily get any vector. Now let me solve another question of this type. We can solve this question. First, understand these triangles. In fact, this diagram. In this diagram, we have two similar pyramids. And this triangle is similar to this triangle. PDE is similar to POA. These two triangles are here. This is PDE and the second one is POA. Well, these two triangles are similar. Now let me read the question. The diagram shows a pyramid OABCP. OABCP, the large pyramid. And the base is a square. This square base means this is 10, this is 10, this is 10, and this is also 10. And the vertex P is 10 centimeter vertically above O. This length is 10. The points D, E, F, G lie on like faces. Well, DEFG is a horizontal square of side 6. DEFG. So all lengths will be 6. And the height is A of this. Now show that A is 4. So by considering these two similar triangles, we can easily prove the length of this A. So I'm taking the ratios of their corresponding sides. So 10 minus A upon this 10, because these two are corresponding, and 6 upon this 10. Hence shown is 4. Well, the second part, BG. How to find BG? This is so simple. You just need to make the way to get BG. So you need to start from B, like BA plus AO plus OD plus DG. This is the way you can get BG, right? BA, because you are working along or parallel to these directions. Don't use these vectors BF and FG. Why? Because we don't have this direction and this direction. So it's better to use these two, this direction, this way. BA, AO, OD, DG. By using this these vectors, you can get BG. It's here. See, BA, I'm writing this notation here. BA, this is for BG, plus AO plus OD plus DG. And their values are, this is 10, this is negative 10J, negative 10I. OD is A, which is 4. And DG is 6J, because it's in the direction of J. Hence the answer is, I think, minus 10I minus 4J plus 4. This is the way you can get BG. This is so simple. And the last part is again the scalar product, GBA. GBA is so simple. I told you always work from center like BG dot BA. BA is given, it's negative 10J. So it's here. BG dot BA. Get the dot product of these two. Multiply this with this, and this with this. The answer is 40. And get the magnitudes of these two vectors and then get the angle. This is the way to use a scalar product and solve diagram based questions. So I have discussed this concept scalar product in detail. Now the next thing is vector equation of a straight line. Vector equations of straight lines. Well, this is the section B of vectors. There are two sections in vectors. I have discussed the first section in detail. Now I will discuss this section in my next lecture. Vectors equation in a straight line, of a straight lines, inshallah. I hope this lecture would help you all to understand the section A of vectors. And this section, inshallah, I'll discuss in my next lecture. Allah Hafiz.